Yes, hello students. In my previous lecture, I explained the continuous conduction mode for single phase fully controlled rectifier fed separately excited with DC motor. So today we shall discuss the discontinuous conduction mode where the armature current falls to zero before the firing of next pair of thyristor. So let us review the previous lecture. We had this rectifier which was feeding this DC motor, which was given a constant field here, which is not shown in this diagram. So what happens during positive half cycle, we trigger T1 and T3, and output voltage, that is the armature voltage, is equal to source voltage. And during the negative half cycle, we trigger T2 and T4, and the output voltage is negative of Vs, so it is again positive, and the current rises and then falls. And in the continuous conduction, it doesn't become zero, but when the load is low, the current may fall to zero before the beginning of next cycle. So let us assume this case that the load torque is small, that is the average current requirement is low. So this means that current will be less. So lesser the current, lesser the energy stored in the inductance of the armature, and quicker it will become equal to zero. So let us see this case. What happens when the thyristors are turned off, current falls to zero, and the thyristors are turned off. In that case, the terminal will become open. This means that the back EMF of the motor will be appearing across the terminal. So output voltage or the armature voltage will be equal to E. When T1 and T3 were conducting, armature voltage was Vs. When T2, T4 were conducting, armature voltage was minus Vs. And when none of the thyristors conduct, current falls to zero. In that case, armature voltage will be equal to E. So let us see here. So suppose we start from here, their firing angle. So here we have given the firing pulse to thyristors T1 and T3. So current starts rising and it reaches the maximum value when V is equal to E. That is the armature voltage is equal to E. We have seen that the current, the rate of rise of current depends on V minus E. So in this period, the voltage is more than the back EMF and current rises. After that, the voltage becomes less than back EMF and current starts decreasing and current becomes equal to zero. We want to trigger the thyristor here, but before that, all the energy stored in the inductance is exhausted and the current becomes equal to zero. As the current becomes equal to zero, this situation arises and the output voltage, that is armature voltage, will become equal to E. From here you can see that current rises and at the end of this positive half cycle, current is not zero. So thyristor T1 and T3 will continue to conduct and they will fall here after all the energy stored in the inductance is exhausted, and thereafter the voltage becomes equal to E. So this is the wave shape of armature voltage in the case of discontinuous conduction, and the current has this wave shape. Now we have shown here alpha equal to 90 degrees in this case, that is we are giving the pulses to the thyristors at alpha, and for the negative pair, that is T2 and T4, we are giving pulses at pi plus alpha. So this is a case. But what is the minimum firing angle? You can see that when thyristors are turned off, when the current falls to zero, immediately after that the voltage here becomes equal to E. So what is the voltage across the thyristors? You can see that the voltage across thyristors after T2 and T4 has turned off, the voltage across thyristor will be equal to this Vs minus E. So this means that at this instant of time, just after that, Vs is less than E. This means that thyristors will not be forward biased. So if you want to trigger the thyristor at this instant, then these will not trigger because the thyristors are not forward biased. They will become forward biased only when the source voltage becomes more than the level of back EMF. So suppose you wanted to have the firing angle this much, and you gave just a pulse to trigger the thyristor, like we do in the case of thyristor, because thyristors are latching device. Only pulses are required to turn on the thyristor. Suppose you wanted to have this value of alpha, and you have given a firing pulse, and then you have removed the pulse. So what will happen? That at this instant, the thyristors are not forward biased, so they will not turn on. And after that, you have removed the pulse. Even though the thyristor will become forward biased, they will never trigger because pulses are not available. That is why in this case, in such a situation, instead of giving a single pulse, we give a continuous gating signal across the gate of the thyristor. So suppose instead of giving this pulse, you have given a continuous pulse, then the thyristor will start conducting after this instant when the source voltage becomes equal to E. So whenever thyristor becomes forward biased, it will start conducting, but the firing angle will not be as we desired. It will be alpha minimum. So it cannot be less than alpha minimum. And this situation, this condition, when the thyristor will become forward biased, is not known to us, because the level of E, it depends on speed of the motor, and the speed of the motor depends on load on the motor. So if the load varies, the level of E will also vary. So we don't know exactly at what instant the thyristor will become forward biased. So that is why it is safe to give continuous firing pulses, that is continuous gating signal, starting from the desired alpha till the end of positive half cycle, like that. And for the other pair, you can give the pulse from pi plus alpha to 2 pi. That is the end of negative half cycle. So this is what is known as discontinuous conduction. And this discontinuous conduction, as I said, there are mainly the reason is a small load torque. If the load torque becomes very low, then the armature current value becomes very low. So lower the load torque, lower will be the current, like this. Higher the load torque, it will become high and it will take longer time to fall to zero. And after certain load torque, the conduction will become continuous. The second reason for discontinuous conduction is low armature inductance. So if the armature inductance is low, again the stored energy is less and it is more likely to fall to zero before the beginning of next half cycle. So these are the two main reasons for armature inductance. Of course, the load torque is not in our control, load may vary, but inductance we can control. We can have higher inductance in the armature circuit to avoid discontinuous conduction. There are certain drawbacks of discontinuous conduction, we shall discuss it later. So we will try to avoid discontinuous conduction, and we want that for the maximum duration, even for the low load torques, the conduction does not go into discontinuous mode. So for that you can add some external inductance in series with the armature to avoid discontinuous conduction. So that is all for today. So we shall discuss in the next lecture. I will do the steady state analysis of rectifier controlled DC motor drive. Thank you.